Okay, so forest biomes obviously are those that are predominated by trees. Biomes are pretty much identified by the type of trees that live there. I'm going to go ahead and take rainfall. That is one of the main primary factors that influences it. But really what we're looking for here is, like we saw with deserts, grasslands as well, as latitude. So whether or not they're at the, what? What's this latitude? Tropical. And then what's this area right here? Huh?
Wait, what? Are you the Earth?
It's not on me, on the Earth. Tropical.
Oh, that's not poles.
The equator doesn't go up and down.
No, this is the poles.
No, he's
Anybody?
temperate.
It's up there, temperate, thank you.
Jeez.
So, tropical, temperate, polar, right? Alright. So, in the tropics, we see they are broadleaf evergreens. That is correct. They keep their leaves year round. I'm going to go ahead and you'll get the point, but I'm going to go ahead and use the term perennials because evergreens is usually associated with. It's still an accurate term. I think there's two N's. I'm not sure. Somebody can help me out there. Spell checking, please. Perennials. Perennials are plants that live through year round. They don't drop their leaves, things like that.
Wait, is that
Okay.
P-E?
P-E-R-E. I don't know if there's two N's or one. N-I-A-L-S.
Wait, there's like plants.
But the idea here, listen up. Yeah.
So there's plants that don't drop their leaves.
Yeah.
Oh, okay.
Which would be an evergreen also. That's another. Now the only reason why I put this up there is because most people associate evergreens with your coniferous things like your pine trees and stuff. But these, of course, they don't have to worry about freezing in the winter. So they're going to keep their leaves year round. They're going to try to maximize their absorption of sunlight because, of course, this is the most intense sun that you have here, plus plenty of water. So you've got that part covered as well. So they're going to try to suck as much as they can out of the ecosystem and produce biomass and tissue right from there. So these are the most productive as well as the most biodiverse terrestrial ecosystems. Okay. So you got your trees, of course. Fast-growing hardwoods. Usually hardwoods take decades to grow. Some of the rainforest hardwoods are almost mature before they're 50 years old, and that's unusual for hardwood-type trees. They have a lot of vines. Vines are well adapted to the tropical rainforest because of the fact that sunlight is one of the main limiting factors in a rainforest. That might seem counterintuitive because they are at the equator where the sun is most is strongest. But when these trees grow and they've got these big leaves and stuff, they quickly produce quite a bit of shade. Okay, so plants, in order to get the sunlight they need, if they're not a tree, then they have to get somehow to get up there to get in the sunlight. And vines, of course, can crawl along and use the trees or other things to make their way up, and vines grow quite rapidly as well. So you see a lot of vines in these areas. And there are plants that do live on the forest floor. They a lot of times will have variegated color patterns. In other words, they won't be all dark green. They'll have different types of phytochromes absorb the filtered sunlight that comes through and everything like that, and well adapted for that as well. When you get interior plants here that people use inside, a lot of times these are from the forest floor of the rainforest because they're adapted to it, because there's not a whole lot of light once you get down there on the forest floor. It's pretty dark actually, even during the middle of the day. So those are the main things in which the way that the producers are adapted for that particular environment. With the consumers, they have to be adapted first of all to being able to eat the main producer. So of course the trees do produce fruit and things, but you remember I talked about trees versus grasses. Trees are more productive, but grasses are more edible. So there are certain things like enzymes and stuff. You get a lot of insects. You get a lot of things like termites that can eat the wood, break down that wood, and other kind of things. Or the termites, of course, they have it's not an amoeba, but it's a protist that lives inside their intestine that allows them to digest wood. And so you have adaptations like that. Transport in the trees. Now we're talking about consumers, which would mean animals. What does this mean? Tree transport. That's a good guess. That would actually be an adaptation for the plants as far as seed transportation. But how about getting around on the forest floor? Do you see a lot of antelope running wild in the rainforest?
Maybe.
No. Why not? I mean, how easy is it to get around on the
It's
forest
really
floor now?
crowded.
Yeah, it's very difficult. Have you ever seen the things where, like the Survivor things, where they put them out in the rainforest or something? It's like impossible to go 10 feet because there's so many vines, so much dense vegetation and stuff. So things move around from tree branch to tree branch, right? So we get, for example, one of the main types of mammals that you'll find in the rainforest? Monkeys, right? Monkeys, of course, are well adapted to swinging and hanging, and many of them, the ones in particular live in the rainforest, that tend to have prehensile tails. You've got snakes; they can go on the branches and things. You've got the flying squirrels and things that can glide through the canopy and other kinds of things. So you have maximized transportation with that dense tree growth. So that's important. You also see toxin resistance. Now listen up, this is a pretty interesting thing that happens, and I think pretty interesting part of the subject of evolution, something called coevolution. And coevolution is when you have two organisms that are adapting with relationship to each other. Now it's easy to see in things that are mutualistic, like bees or bats and flowers. And that they have specialized, proboscis or whatever, very long tongues to get in there and lick up the nectar, and then they of course then help the plant to fertilize, to cross-fertilize. But there's also a competitive type of coevolution that takes place when two things are basically battling against each other. And in the rainforest, since there's so many insects that are trying to eat these trees, all the different parts of the trees, unlike the grasses, which recover well from that kind of consumption, these don't. And so the trees that produce a lot of toxins to do that. There's a lot of toxic plants in the rainforest. That's why they go there to find medicines. And so you get insects that have evolved resistance to those toxins. And so it goes back and forth. The plant will produce a new toxin. They'll get an insect that is immune to that. And natural selection will cause that insect to populate more, and so forth, back and forth. And you tend to end up getting some very toxic plants as well as toxic insects. And also the things that eat the insects. As a matter of fact, there's one little very brightly colored creature that lives there in the rainforest that is poisonous. Not so much with the newts.
The frog?
Yeah, the frogs, the poison dart frogs. Okay?
The green and orange.
Well, they have a lot of different colors.
Blue.
Some are blue. Alright, so anyway, enough about the colors.
Yellow.
Fact is, these animals, like a number of toxic animals, like the blowfish, listen up please, are only toxic because of what they eat. And their way of dealing with those toxins that they're getting from these toxic bugs that they're eating is to excrete them out through their skin. That's the toxic part of them. Has it served them well as a warning to keep them from getting eaten? Yeah, perhaps, So it's double duty there, but it just basically is a way. Remember bioaccumulation? You deal with things some way. Now with amphibians, they can excrete it out of their skin pretty quickly because that's like a main type of organ for them there. They're not going to do the same things we do with it, but same thing. That's like I said, that's what makes them toxic. And like the blowfish in areas like the Indian River here, where they're not eating toxic coral, you can eat them without having to worry about the fugu poisoning. But
Wait, so
that's a different
if
subject.
you own one of those dart frogs, they're not actually poisonous, and you have
That's absolutely correct. You can raise the dart frogs and stuff in their own environment where they don't have toxic food to eat, and they are not toxic. Yeah.
But they can be colorful, right?
Yeah, they'll still be colorful. All right, listen up. Last column here. Pay attention, please. Soil composition. Folks affected by decomposition, but soil characteristics. The rainforest soil is actually quite thin and not very nutrient filled. Surprisingly, a lot of people would think it's very good, very rich, but it's not because you have very rapid decomposition because of hot weather, lots of rain. So the bacteria and funguses break it down very quickly. You have a lot of denitrifying bacteria in the rainforest, and then so you have so much rain that the erosion both washes the soil out as well as leaches the minerals out of the soil. So rainforest soil is actually pretty weak. That's why you get another thing. Let's go ahead and put this in here, by the way. One type of plant that's very common in the rainforest are epiphytes. As we call them, air plants sometimes. And the reason why they call them air plants is that they don't actually root in the soil. Our Spanish moss is an epiphyte, by the way. And these typically, a lot of these grow in the trees. They'll grow on the branches of the trees and stuff. And since they don't have soil, it doesn't help much to be down there in the soil of the forest floor anyway, because it's weak anyway. But they will then, their leaves are designed to trap water, and then bugs will come in to drink the water and stuff and hang out in there, and some of them are going to die there, or leave their waste products at least. And that is the fertilizer source for these plants. Bromeliads, for example. Anybody have bromeliads as a
They
plant?
look like bromeliads.
Huh?
I say bromeliads.
Bromeliads.
They look
is
like
the-
bromeliads.
Okay, the way to pronounce it is bromeliads. But
I will continue to
anyway, you notice how they're like the water collects in them and stuff. That's part of what I'm talking about. It's their own water supply, keeps it there, so they don't need soil to hold the water, and also stuff goes in there and bugs and stuff, and that provides a fertilizer. So it's an adaptation. Any questions about the rainforest? Yeah.
Like the epiphytes, they're like they're at like trees that are adapted.
These are plants that don't need to live in the soil. They tend to live in the branches of the trees. Think of Spanish moss, like we have in the oak trees and stuff around here. Okay. All right. Deciduous forest. Now these are ones that decide to drop their leaves every year. They do have broadleaf trees because they do have a relatively hot summer. Usually, they tend to have a pretty high to moderate to high amounts of rainfall. Not quite as much as the rainforest, of course, but pretty good. And they get snow a lot of times. Snow is a type of precipitation, so that helps the trees as well. And since they do have a relatively long summer, they are going to use broadleaves to maximize that. The latitudes are such that they can still get a fairly intense sunlight during the summer. But winter comes, and that's a liability to have these water-filled leaves on your tree, so they drop them. Before that, what happens? Nick? Before they drop the leaves?
I'm assuming that they just collect water while they're on.
Okay, no, we're past epiphytes now. We're on deciduous forest here, so let's keep up. Anybody, what happens to them? What happens to the leaves before they drop them?
They freeze.
They turn different colors, right? Yellow, red, purplish, actually. This is, I think, kind of a really interesting adaptation in that they switch to a different type of phytochrome, which chlorophyll is a phytochrome that they're using during the summer.
Teachers and students excuse this interruption. At this time, all testing students have been released from the media center. They should be arriving back to your classrooms in the next 3 minutes. Thank you.
Okay, so what happens during the fall is, of course, the sun, as we go towards winter, the sun is at an ever-increasing angle, right? So that means that the sunlight has to go through more atmosphere. What happens to sunlight when it goes through a thicker atmosphere than when it's overhead and going through the least amount of atmosphere? We see this at sunset and sunrise also.
Weaker.
It is weaker, so that's true.
Right?
What happens to it?
Diffuse.
You're close. Diffuse, it does do some diffusion. It's also starts with a D. It happens to light as it goes through different materials. Physics people?
Yes.
What happens in a prism? To light. It gets diffracted. Okay? So as the sunlight, this is what happens, of course, during sunrise and sunset when we see all the pretty colors and we see the sun's a different color and it's bigger and stuff. That's because it's going through a thicker atmosphere. Well, same thing, even at noontime in the fall, the sun's going through more and more atmosphere as it comes to these trees, and therefore it is diffracting. We don't see it so much. Of course, in the sunrise and sunset we do, but it's still a different wavelength of light, and therefore these colors actually adapt better to those wavelengths of light. We see the same phenomenon with coral reefs, because the algae in the coral reefs has got to stay down there with the coral reef. It can't do like plankton, or it can't grow up like kelp to the surface, so it has to use the sunlight that is going through the water. Water diffracts that sunlight even more, and so it uses a wide variety of these chemicals. They're dyes, basically. Chlorophyll, xanthophyll, Dr. Phil? I don't know. There's another one. That's probably not it. But it uses those because they can better utilize the different wavelengths of sunlight that's getting, because it's going through In this case, through more atmosphere. In the case of the reef, it's going through water, which diffracts it even more. So that's why we get different colors, and makes nature beautiful, of course. And it works. That's what's great about nature. What kind of consumer adaptation do we have? Once again, hibernation gets cold, so you see that some of that, a lot of migration. You know, it doesn't get super cold, and you're close enough for a lot of species to be able to migrate into more tropical areas as well. So it's pretty common in these type of habitats, and you get a lot of adaptation to deal or to utilize the leaf, not leaf lettuce, leaf litter. And you guys maybe, hopefully remember we did a little free response question about that, about the worms that are eating the leaves on the forest floor and stuff like that. This particular ecosystem, it is well adapted to. That's a big phenomenon there, having almost all the trees in a forest drop their leaves at about the same time. That's a huge amount of biomass that goes on the forest floor that has a number of different effects on the physical characteristics of the forest floor. And so everything, of course, is then adapted to that, whether it's burrowing down in there, whether it's eating the decomposing leaves themselves, or whatever else. So you see that. You also, because of that, have a very thick topsoil, very nutrient-rich topsoil from these decomposing leaves.
I think it's like Malaysian Airlines, but
Okay? So that is your typical deciduous forest. Questions? All right, finally, taiga. This is our Christmas tree forest, our coniferous forest. It is a subpolar, I'll take Arctic. Not exactly right, because we also have some in the southern hemisphere, although most of them are in the northern hemisphere. So it's subpolar. What's your polar biome? Well, we got the north and south pole, but what is the biome that is not just ice? Yeah, the tundra. Very good, thank you. So this is a little bit below that, latitude-wise, or closer to the equator, latitude-wise. It gets enough precipitation. It gets lots of snow, and so that's enough to support trees. They do tend to be your evergreens with needles that are filled with sap. They don't get, that much sunlight, direct sunlight, because of their latitude, so they don't need broad leaves, or they wouldn't help them that much. And of course, these would end up freezing in the winter. So needles and sap, they don't freeze that well. And then you have also animals that are adapted to the really cold. Now this is really cold, not as cold as the tundra, but definitely colder. Yeah, now the moose, how's the moose adapted?
Well, because they have a lot of fur and they can eat the needles.
The second one is actually the more of it, and I guess they have their whole bodies covered with fur. I don't know, I think it is, but yeah, moose are one of the few animals that can eat pine needles. Still on planet Earth, didn't you? Or did you? Okay.
Yeah,
That's good.
about the taiga, there's like a whole thing on the taiga and the Arctic tundra.
Right. So we might watch those if we have time. So anyway, fat and fur, of course. Those are your main insulators. You do have hibernate. You have hibernation. You also have some burrowing here, although not as much as you might as in the tundra. No, not moose. But of course, it's a pretty dense forest, so it's hard to burrow, as you might imagine, in a forest with the roots of the trees and stuff there. But that is also an adaptation. And like Caroline's told us, the moose and other types of animals are specifically adapted to consuming. Not a whole lot is that edible on a pine tree or a spruce tree or something like that.
The birds can
With
eat
the little
seeds,
berry
and
things, yeah.
Their beaks go like this,
Yeah.
and it opens it up, and their tongue goes.
Yeah. They excite you.
Yeah, it does.
All right. Now, because of the slow rate of decomposition, because it's cold, the topsoil is not that thick, and also you don't have, the needles stay on most of the year. You do get, of course, some of them fall off, but not anywhere near what you get in deciduous forest. And then also needles, they're very high in sugar content. And when you have a high sugar content, bacteria will break that down and make acids out of it. That's why you got to be careful with, sugar will rot your teeth. You have things that you leave in there for a while. The bacteria that like to eat sugar will produce high levels of acid. Same thing happens in the soil here. So acidic soils don't hold minerals very well, so it's kind of weak soil, but it's enough for these trees. So it's nutrient based. I don't know what that means.
You said that.
Nutrient based soil? What would that mean? Nutrient poor soil. So not the greatest soil out there. Any questions about forests? Forests.
Okay.
Succession literally means the order of one thing following another one or following something else is a type of succession as well. In ecology, it is what happens when you start off with a new environment. We will talk about terrestrial succession now, and we're going to do aquatic environments later this week, so we'll talk about aquatic succession then. And it is, in its primary form, it's very rare. You need some very specific conditions, such as lava flows or landslides. That'll work. We went with mudslides, same thing, same idea. But basically, whatever exposes bare rock. Okay, so you got rock, and it's flat enough that it'll hold what? What's the other ingredient that you have to have for life always?
Water.
Water, yeah. So it's flat enough that the water can pool up on it, sit there for a little bit. You have the potential for life to form and start on that. Okay, and so not a whole lot of things can handle such bare conditions, but lichens can. Lichens are one of lichens and mosses are typical organisms that can do that kind of thing, called pioneer organisms. And one of the reasons why lichens are able to do this is that they are actually two organisms. They're a mutualistic organism, very similar to the coral that has the algae inside of it. Lichens are a fungus that has an algae inside of it. Okay, as a matter of fact, you'll see there are a variety of colors, and that once again is from the algae cells that live inside the fungus cells. So that's good because you have a producer and something to break down the waste products of that producer so it can get its nutrients again. So you have a little ecosystem of its own just within that organism. But they need places to stay, and they need a place for water to collect. They, of course, also need that water. So they'll move in, they'll sit there for a little while. As they're there, they will, for one thing, they'll physically, with little projections, they're not really roots, but they'll push little parts of them down into the rock to hold themselves in place. That, of course, breaks that rock up. They will also decompose, and that will secrete acids, which will dissolve the rocks up. So you're going to end up having that rock that they're on become little smaller bits of rock, kind of like sand. And then you have the decomposing pieces of lichen, as well as anything that comes along to eat that lichen that may leave its waste product there, bugs or birds or something like that, or might actually die there and contribute to the organic content there. So you've got bits of rock, sand, and you've got organic content. Those two things together make what?
Life.
Well, they help to contribute to life, but
Soil.
Soil is correct. Very good. So what we see for how a typical ecological succession progresses, it's mainly based around the buildup of soil. This is in terrestrial ecosystems. Okay, so you got the lichens there. They got some bugs that come along and eat it. They die. The lichens die. The new ones grow up, but they leave the old decaying matter in their place. They break up the rock that they're on, etc. That provides the mineral content. Eventually, the soil gets thick enough that it can support grasses. The grasses attract other consumers, birds, etc. They come in, they once again leave their waste products, the soil builds up more, small bushes and shrubs can come in, and it will continue to go through that process as the soil builds up with larger and larger plants all the way up to hardwood trees. If, of course, the physical conditions allow for that. If there's enough water in that area, it's the main thing, and it doesn't have permafrost to support trees, then eventually you should end up with in a place where you have a fully developed forest. That soil formation, by the way, is called penogenesis. It's a little key term out there. So that final stage is known as a climax community. But I want to stress to you here that not all areas are going to become climax communities. Otherwise, the whole earth, of course, will be covered with forests. So at what point an ecosystem has reached its climax stage is dependent upon the environmental conditions there, primarily the climate conditions. So deserts are actually climax communities because in that area that's as far as it's going to go. Okay? So we tend to associate that with forests, but it doesn't have to be that way. Type of the organisms that exist there is in this environment depends upon, in this, biome is what we're looking for there. I'll accept environment. That depends upon the climate, primarily, as we have seen. And not only may it not reach a forested climax community stage, like a desert or grassland, but it also might become a fully evolved community, become a climax community, a forest, and something could happen to it. As a matter of fact, this occasional clearing of big parts of the forest through fires and foundational species, floods sometimes do that as well, is necessary. It's important for it. Because what happens when these forests get all the way grown up and maxed out, so to speak, is the trees lock up all the nutrients and they inhibit sunlight from getting to the forest floor. So you end up with a mature forest and you got most of your biomasses in the trees. Now they can support a pretty wide variety of life, but it's still not the most biodiverse state for that to be in. So what is actually an ecological necessity and promotes biodiversity and productivity is that occasionally these things will have fires, they'll have foundational species like elephants or termites or something like that, or beavers come through, and or humans, of course. Now we tend to do it to the excess, so we don't like to put that in a good light. But when it's done in small amounts, and particularly with the older trees that live in the forest, they're going to be more susceptible also to these different things as well because their wood is not as dense anymore. It makes way for a new generation, so to speak, and you have this stage where it goes through all that whole successional process again, which means more species, more biodiversity, better for the ecosystem. Okay, biomes are your climax communities around the world for that climate. And it says worldwide distribution, as I mentioned the other day. In order to be considered a biome, it has to exist on at least 2 continents. Okay, the main thing that we identify biomes with are their producers, and those producers tend to, of course, be adapted to the climate.
What is the last one say?
Mountains.
So what does this say, Group 7?
MTS mountains.
Mountains.
That mountains, Group 7?
MTS. Shouldn't there be an N?
That is correct. That's an answer. We will go ahead and spell it out. So of course it gets colder as you go up a mountain, and therefore you have the potential, particularly if it's a tropical mountain like Mount Kilimanjaro or one of the Andes, to go through several biomes as you go up that mountain. You would start, if you're in a tropical area, you would start at the bottom of the rainforest, and then go through a deciduous forest, and then a coniferous forest, a taiga type forest, and then you may have a grassland and tundra before you get up to the top where it might be cold enough if it's a tall mountain to have a ice sheet and an ice field and everything there. So that pretty much cover all your different biomes in one particular area. And then another effect that mountains have is called the rain shadow. Any idea what that is? Rain shadow, rain shadow. Rain shadow. Mountains do this. Rain shadow. Right, that's where the mountain range blocks the water. So if you've got a mountain range like the Himalayas or like the Sierra Nevadas,
On the other side.
yeah, you'll have one side where the water comes up. It's going to be nice, lush forested areas in that area. But on the other side, you'll have a desert because the clouds cannot make it across the mountains, and therefore it's much drier. So you'll have grasslands and deserts and stuff on that. This is true of the Mojave Desert we have here in the United States. That's primarily, well, it's on the 30-degree parallel, but it also is affected by the Sierra Nevadas that block the rain coming in that way, and of course the Gobi Desert in China is on the north side of the Himalayan mountains, and of course there's not any clouds are going to make it across that one, very few. Okay. Questions, anybody, about succession? Yeah, Jimmy.
I feel like I've already been explained this, but what causes the temperature to change as you get higher up?
The air density is lower as you get higher up. What causes temperature change is because the air density. All right, forestry products are a renewable resource. How so? Why are they renewable?
Grow back.
You can grow them again, you can grow them back. Okay, so when we have a renewable resource, we can theoretically continue to use that resource as long as we use it at a sustainable rate, which means as long as we use it to a level where it can regrow itself, or as we've talked about, water resources, freshwater resources, resupply itself. And if we don't exceed that level, much like a bank account, we'll always have money in the bank or trees in the forest to utilize. What do we use these particular resources for? Main things we use, timber. By the way, timber is the collective term for just cut trees. We use it for lumber, paper, and fuel, and I'm not actually sure of the order, so that's just a random order that those are put into. As a matter of fact, because they're renewable, there's been a lot of effort put into developing power generation plants that use wood. They pelletize that wood. They make it into little bitty pellets and stuff that'll burn very easily, and you can get a pretty high temp furnace going. That of course is enough to boil water and generate electricity. So that's the type of biomass type power plant that is becoming more popular. The whether or not you do sustainable forestry management, of course, is going to be we're going to rely upon how much you take out, but it's also mainly going to rely upon how you remove those trees from there. The worst method, the one that has the most environmental impact and the least likelihood of that forest being able to recover, is through clear cutting. And as the name implies, you just come in and cut down everything, including the trees that you don't want, including the ones that are too small or of a variety of that is not usable for you. But you cut those down too, because access is a big hurdle to overcome when it comes to cutting down trees and things. And even though selective cutting is the best way, it is much more labor intensive and therefore, of course, harder to do. So this is for efficiency. You can go in and cut down everything, no matter what it is what type of tree it is that's in there. Another type of this is still considered clear cutting, but is a little bit better, is strip cutting. So it still has some of the efficiency that you get with clear cutting, because you don't have to pick and choose. You don't have to get your equipment in there, close and stuff, and pull things out. You can just go as you go along. In strips, I'll take rows, is of course same idea. And you will typically do that along the contour of the land, which tells you one of the big things that clear cutting, just simply by itself, one of the big problems that it produces, and also one of the reasons why those forests don't recover very well when it happens, is that you get a lot of soil erosion. Of course, once the soil is eroded away, it's very difficult for things to grow, and then you get all the water pollution that's associated with that as well. And so consequently, if you cut in strips, then you have barrier strips of forest that are left along there that can help to catch the runoff and also block the wind from coming in and blowing away the soil and stuff like that. And of course, you also have trees around the strips that can reseed and everything, those that are in those particular areas. And as far as selective cutting goes, there's shelter wood cutting, which means that you mainly take out the mature trees. Those are the ones that are harvested. And this follows along the lines of natural selection. Natural succession. In that, like I said, the things that affect, when we have those clearing events, the things that affect trees the most will affect mature trees even more so. A lot of these are at the end of the lifespan. The wood's getting a little brittle. Of course, if it's so old that it's, the wood is completely eaten up with termites and stuff, that's not going to be of any use. But those trees are not as productive. They're not producing seeds a lot of times anymore, so they don't help the rest of the trees in the ecosystem. And therefore, cutting them out of there is in a way, a service for that ecosystem, as long as it's done practically. And that's shelterwood cutting. Seed tree cutting is another process. You do cut more trees when you do seed tree cutting. It is less selective, and you do harvest more when you do this. So shelterwood cutting, in that respect, is better than seed tree cutting. But in seed tree cutting, you do relieve the trees that are at a particular seed-producing age. Trees, like other organisms, have a certain period in their life when they are more reproductive. There's a young age where they're not producing pollen and seeds and stuff, and then there's an age where they do it maximally, and then there's an age after that where you would cut it in the case of shelterwood cutting. But for obvious reasons, you leave the seed ones in there, and that helps to repopulate the forest. Now, one of the things, the techniques that active forest companies utilize, companies like Georgia Pacific, for example, is a big forestry product company, is they do a rotation schedule. So they will harvest from one section of a forest and then move on to another section of the forest, and then they'll have a rotation as such that by the time they get back around to the original patch of forest they started in, it will have regrown to the point where they can harvest from it again. And that way they can continue to utilize that resource in that forest area again and again, and continue to get the forest products out of there, as long as the amount they take out is not too great, and as long as the cutting techniques that they utilize are forest friendly. Okay. All right, so different types of forests. We have old growth forests. These are ones that are at their climax community stage, and they tend to be ones that have hardwood trees in them. Sad thing about this, much of the old growth forest, particularly in temperate regions, where we've seen a lot from civilization. If you remember last week, I talked about how grasslands and temperate areas of prairies have been mostly converted over to agriculture. The same is true of a lot of your temperate forests. They're, I think, at like 5% coverage from what they were 300 years ago. That's sad, because they're really beautiful ecosystems, but they're in areas where people want to plant crops and things like that. And also the wood that's there is expensive, so that makes it, of course, valuable. So we see a lot in the rainforest, a lot of areas around the world where people are going in and harvesting trees from the rainforest. Some of them are doing it sustainably using selective cutting, but all too many of them are just using clear cutting techniques. But you take, for example, a teak tree that's more than 40 feet tall, which it doesn't take that long for in the rainforest to get that tall. That's worth $5,000 or $6,000 because of the value of the wood and everything. So you can imagine that these companies will go in. They're not in that situation a lot of times. And this is another example of where, when you have a developing country, when you have places that are poor, the business mode is more of maximize your profit on the front end and not worry about what's going to happen 20 or 30 years from now. So they don't have a problem with doing clear cutting harvesting, because they're not thinking, oh, well, we want to come back 20 years from now and get some more from here. They're thinking we're going to get whatever we can and get the heck out of there. So the rainforests still do have significant amounts of old growth forest, but that's about the last place you can find large expanses, and they of course are under pressure and threat as we speak. So that's your old growth forest, completely grown out, hasn't really had human impact or harvesting or anything like that. In 200 years is kind of the average time it takes for a hardwood tree to mature. Less than that, probably about 100 years would be more accurate in rainforest. It takes about that long for something from the rainforest to mature. Your second growth forests are ones that have been harvested from in the past 200 years, and they may be on an ongoing, like I said, rotation, where people are going in and obtaining those particular products. They tend to contain mature softwoods. Those are a lot of times harvested. These would be mainly pine. Most of your lumber is pine, and most of your paper products are made from pine. It's a very hardy tree, very widely distributed, and it grows very fast. Your softwood trees, most of your evergreen trees and things like that, in a warmer climate, they grow very fast. So that, of course, is an advantage to people in the tree business and things like that. They're not worth as much because just the old supply and demand kind of thing, but they have a lot more utilization from other ones. You will also in these forests, of course, have some mature hardwood trees, or young hardwood trees that are still growing up. But remember, it takes about 200 years for them to become mature, so depending upon what stage you're in, you might have some of the younger ones of that type growing up in those areas. And then finally, you do have tree plantations, and those are, as the name implies, farms that are set up specifically to plant and grow trees. A lot of these types of trees are ornamental trees, or they're trees for the different agricultural industries, like fruit trees and nut trees and things like that are going to be sold to farmers and planted, etc. So they need to grow them whole, and a lot of times they'll keep the root ball secured and stuff so they can transplant it. Now, here's the thing about these tree plantations. A lot of people say, well, we should get our forestry products, things like that, from these, so we're not out in the wild taking it from the natural environment. The problem with that logic is that if you're going to make a tree plantation, chances are you're going to make that tree plantation where a forest would normally exist, because you're going to have the rainfall, the sunlight, and all those other kind of things. So if you say, well, I'm trying to save the forest by cutting down 100 acres of forest so I can put up a tree plantation, that doesn't make a whole lot of sense. So that's why I say properly managed, sustainable forestry techniques, as long as they're not, you don't go over it, as long as they're sustainable, can work out well. Is it as good as a natural undisturbed environment? Of course not. You have environmental impact of people when they go in and cut down the trees. A lot of these are also fertilized, and they use insecticides and stuff in them because, of course, trees need fertilizer and they get diseases as well. So those, of course, are also environmental impacts from it. But if you do harvest from there sustainably, you can continue to do so year after year. Any questions about forestry? Alrighty. There's